Good morning, everyone, and thank you for your time and attendance this morning. We would like to provide you with the knowledge and expertise of our Swagelok Local Sales and Service Center, as well as let you know Swagelok globally as a company is here to support and deliver the same service we had prior to these challenging times. We will begin our session right at 10 a.m. as we do understand that time is a priority these days. Just wanted to give a 5-minute interval and allow people to have some time to still get on the line. We'll start within 5 minutes. Thank you very much for your time again. Good morning, everyone. Thank you again for your attendance. This morning, our virtual training will be around mechanical seal support systems and best practices. My name is Katie Whitman, and I am the marketing representative for Swagelok Southwestern Ontario. And I'm just going to give a brief summary about our local sales and service center. Swagelok Southwestern Ontario services the Sarnia area as well as Windsor and Essex County, leading all the way east to Hamilton, Burlington, Oakville, and we also cover the Niagara region up to Bruce County, north of Bruce County. The core industries we cover but are not limited to are chem, petrochem, refining, steel making, power generation, and both nuclear and fossil fuel, semiconductor, and automation. A brief snapshot of our products, but certainly are not limited to our tube fittings, valves, hoses, quick connects, and today's subjects, mechanical seal support systems. We have also branched into services over the last 15 to 20 years, which have also helped with our custom solution offerings, which include panel assemblies, skid fabrication, and sub-assemblies at our local shop in Sarnia. We have a field service component in our services, which includes compressed gas leak detection, hose evaluation, sample system evaluation services as well. Today's presenters and hosts include myself, who I've already introduced, Richard Webbs, who is our regional field engineer, as well as Sean Hunsinger from Swagelok Corporate to present out on this topic. I'm going to pass this over to Richard right now and let him give a quick intro of himself, and I hope everyone enjoys the presentation. Just a reminder, the Q&A is on your right-hand side. Feel free to answer any questions you have throughout the presentation. Thank you very much again.
Thanks, Katie. Good morning, everyone. Welcome. I am the regional field engineer for Swagelok Southwestern Ontario. So the topic that Sean will talk about today, I'll be available to answer your questions through the live chat, and also in the future, more than happy to come on site and have a look at your challenging applications. So, Sean, please take it away.
All right, thanks, Rich. I'm gonna turn my camera on here and send that live so everybody can see me. All right. Okay, so today's presentation is on seal support systems applying the best practices of API 682, the 4th edition. All right, so everybody's on mute right now. Please ask your questions via the chat function, and recording of the webinar will be available later. Okay, for today, I'll touch on just briefly some history and objectives of API 682, look at piping or tubing as a method of connecting these systems, and then really focus on two major pieces of designing these systems, and that's really considerations about designing for reliability and safety. So we'll get into some examples of where the standard references good guidance for designing for reliability and safety. Okay, just a brief history on API 682. It's only about 20 some years old. 1994 was the first edition. For a period of time, ISO and API were collaborating. They are no longer doing so and not co-publishing any longer. So really what we have kind of the global standard right now. I don't hear ISO referenced so much, pretty much around the world. Anybody dealing with petrochemicals is discussing API 682. All right, we're expecting a new version of the standard sometime in 2021, 22. They really try to update that about every 5 years. Okay, I think the first thing when we talk about 682, that's a good thing to start with, is that it's not a code. It really is a place to share best practices. A lot of guys will say, hey, we got to follow exactly what's in API 682, but I think what we'll talk about in this presentation is a little bit about where you may decide to deviate or make changes or improve upon some of the suggestions in API 682. All right, we always start with API because it is the gold standard for seal support systems. And then if we deal with an ANSI application, some chemical plants will have that, both API and ANSI applications. The discussion here is relevant for ANSI systems as well. You just may be able to change some of the componentry around, as typically ANSI service is not as heavy duty as API service. As you know, Swagelok does not make a pump, does not make a mechanical seal. That is not our core competency. What we are really good at is designing and building systems like seal support systems for the conveyance of fluid and gases. So basically anything 2-inch and under is in the wheelhouse of what Swagelok does. So today we're going to focus on really the seal support systems, which is a key aspect of seal integrity itself. I look at two sections, section 8, which gives me all my guidance on what type of accessories I need to use and key considerations for things like sizing, seal pots, etc. And then I often reference Annex G, which gives me the standard piping plans and the hardware that goes on it. So it gives me the design of each plan. Even today, if somebody says, hey, I need a 22, sometimes I got to look in the book and say, okay, this is what the components on a 22 are. Throughout the entire standard, there's a big focus on designing these systems for reliability, safety, and ease of maintenance. So 3 big considerations for us there. I did want to highlight one thing because we are seeing tubing being used in these systems quite often. This is an article from Hydrocarbon Processing. A gentleman I worked with, Heinz Block. He's fairly well known in the industry, worked for Exxon for a number of years, and is a real guru of rotating equipment. He's a real advocate for using tubing in seal support systems. So when you look in the back, it says piping plans. Well, now designers have a choice. Do you want to use piping or do you want to use tubing? And certainly we see the major seal manufacturers and pump vendors using a lot more tubing. So I did want to point out something for the group here. These are the charts for piping and tubing from the standard. Make sure that if you are using tubing on these systems that you're using the appropriate wall thickness. I've highlighted here the wall thickness requirements or recommendations for API 682 for 1/2 inch through 1 inch. This is traditionally a little bit heavier wall than we use for the pressures and temperatures we would typically see in seal support systems. API likes to beef up the wall a little bit, use a heavier wall tubing for not pressure containing inside the tubing, but really for external robustness. These are around pumps, equipment, and they certainly don't want a guy putting his hand or foot on something. So they really want to have external rigidity with that extra heavy wall thickness. I bring it up here because if your guys are going into the storeroom and just grabbing tubing, they just want to pay attention to the wall thickness and not grab instrument wall thickness tubing, which would have a thinner wall on it. You'll also notice there's no guidance for tubing below a 1/2 inch. That we typically see on gas seal plans like 72s and 74s. We just size that wall appropriate to the pressure and temperature service. And same goes for over 1 inch. We have a lot of OEMs using over 1 inch tubing on compressor systems or pump systems. And then we just size that wall appropriately for whatever application they have. Okay, so let's just jump into designing for reliability. What I've pulled up on the right there is the ISO diagram directly from API 682. And so this is my common reference right here. What goes on a plan 12? Well, it's an orifice and a strainer. So I look in the back. One of the things below the ISO diagram that I find very helpful is the text that they have talking about, considerations for it. And one main considerations for this design is that it has not been proven to have a 3-year successful operating life. Does that mean that we shouldn't use this plan or we can't use this plan? No, that's really not what it means. It's just saying that, hey, pay attention here. There's probably something on this design that needs servicing. And in this case, it's going to be the strainer. That's a reliability concern. If we don't have the proper preventative maintenance plan to blow that down, it can become clogged and then affect the flush flow in my plan 12. So I always look in the back just to see, hey, are there maintenance considerations with these plans? All right, so, with that designing for reliability, we want to reduce leak points wherever we can. All right, that's a big concern. Whenever I go throughout the world to Asia or Europe, we're always looking at reducing any potential leak points. So we want to always look at these designs and say, hey, where can I engineer out potential leak points? However, we also want to consider that these systems don't have to be static, and sometimes I might need to add additional instrumentation. So just because API says that it's this way in the back of the book, if I'm having problems with this system, it might be necessary to add additional instrumentation. So I'll give you an example here. And this is a plan 12. This was at a customer site. They had to change the design because they had issues with that strainer clogging. So for a period of time, they added gauges on either side of the strainer to measure when the strainer, how frequently it clogged. And they found that it clogs about once every 3 months. So they wrote the preventative maintenance down so that they would blow that strainer down every month or 2. So after they diagnosed this problem, they removed those gauges and reduced those potential leak points and plumbed right back into that strainer. So it's quite possible then to think about API as, this is the way we want it to be, but at some points I may have to actually add additional instrumentation as a diagnostic tool. And then there's no problem removing that later once I've, figured out whatever we need to figure out. All right, so just to give you guys some few more pictures, this is from a fracking field in southeastern Ohio where they're taking grass out of the ground, doing a little bit of light separation and processing before putting it into a pipeline. This plant was less than a year old. already I'm seeing some issues, and they were having some problems around pumps, even a relatively new plant. This, what you're seeing here, is a 5211. So it's a seal pod on the left, and then you can see here I've zoomed in on the 11. Sometimes the gas was not clean. They had, particulate in the gas coming out of the ground, so they had plant 11s that were clogging. Again, we see a plant 11 is just an orifice. If that clogs, the only way they knew about that would be to have a seal issue. So there's an opportunity there to add additional instrumentation if they were having clogging issues. Next thing I'm looking at here is the connections into the seal chamber from the 52. We got 1, 2, 3, or 4 fittings there. Again, we always want to use one fitting whenever possible, as few connections as possible around here. We certainly don't want this to leak, especially in days like we're having today, where it's cold overnight, freezing, and then it thaws during the day. That expansion contraction works at pipe threads, loosens them, and then you do get leaks. And this is really not a great place to have a leak. And certainly the last thing I'm looking at here is this hose. API does not recommend using hoses in these applications. You can use them in ANSI, but for API, we always want to use rigid piping or tubing whenever possible. I don't know when that hose is going to fail. I just know it will fail at some point. Certainly the routing of the hose is an issue. But whenever you're possible, just try not to use hoses in these applications. They are wear items. They are going to fail at some point. So in pursuing an elimination of leak points, just make sure your guys have the appropriate fittings. When you're out there reconnecting, putting a seal back in, hooking up a flush systems, there are products out there that help you eliminate leak points, single fittings that make the transition. Try to equip all your people with that instead of having them just go to the back of their truck and pull out whatever they have in the back and cobbling something together. That picture in the middle there, they're using a hex coupling and then a tube fitting. That could be done in one fitting. Why introduce additional fail points if they're not necessary? And in eliminating leak points, I also look for places where somebody in the maintenancing of a system could have an issue. So I'm looking at right here is where they've added welded together a piece of piping to add a thermometer. Now, the dangerous thing here for me when I'm looking at this is, what if somebody, if that thermometer fails, puts their wrench on the thermal well and unthreads that accidentally instead of just the thermometer? So, this is a potential safety and reliability concern here, because there's an additional leak point in where somebody could accidentally disassemble it. So, again, look for ways to add temperature or instruments where they can be safely isolated, block bleed, or not able to be disassembled. So we look at situations here where you can use a fitting to add a gauge, where you have the thermal well welded into the fitting. So on that right here, I'm looking at a Plan 52 where they've added temperature monitoring to the inlet and outlet to the seal pod. Now, that's not recommended in API, but this site felt that it was important, instead of having guys walk up to these systems and just putting their bare hands on the tubing and trying to judge whether they're getting the right flow in and out of the seal pod, why don't we just add temperature measurement, and so that the guys can look at it easily when they walk up to the pump. So even though this isn't recommended on API, the site found value in it, so they decided to deviate to add that extra information. Okay. One other thing in API that is around instrumentation that's relatively new is the recommendation to add block and bleed valves to everything, even our gauges. And while this may sound like something that's a no-brainer, I, in my travels, have seen tons of process gauges threaded directly into process piping with no way of isolation. And then that gauge eventually fails over time, and it's stuck there until there's a turnaround or a project where things can be removed and taken out of the system. So, you can see here, this is a between bearing pump. We've got orifices on either side of that T coming out the discharge. So they've added some gauges there to monitor the pressure drop across those orifices. And best practice right here, they've added a way to block and bleed those gauges off. The instrument is only as good as its ability to be used and replaced if it fails. So make sure we're considering, how is this going to be serviced? All right, Rich, I'll let you do a little explaining on this slide here.
All right, thanks, Sean. So locally, we've been able to help our customers out with gas sealing systems. In particular, Plan 74s and Plan 7276s. Some of the nice things that we've done for our customer that exceed the requirements of API 682. We have a bypass arrangement that's set up on the flow meters, so you can bypass the flow meters and do some calibration work on those flow meters, and some additional testing needle valves that we've added, so that they can go around and verify that the system is working well. One of the other nice things about these particular panels is they're very compact, and they also utilize not just Swagelok product, but also customer-specific products such as Rosemount transmitters and Brooks flow meters that are explosion-proof. And one last really nice thing for those who require compliance to TSSA, these panels do have a Category H registration, so they basically install like a fitting into your system.
Good, thanks, Rich. That's nice. So, what I'm looking at here is the discussion between, putting things on panels, and then are we going to be using transmitters or switches? The panel here done locally on the right, the Plan 74 incorporates a transmitter, which makes sense on a 74. I'm flowing clean, dry nitrogen into my seal. I want to monitor that. However, on a Plan 76, maybe a pressure switch is the better option, since I'm really only looking for a high level alarm when I've got my normal leakage and nitrogen being swept to flare. I just want to know if there's a catastrophic failure. I don't need to monitor that leakage at all times. So even though, we're moving towards a world where there's transmitters on all these panels and they're looking more like instrument panels than ever, it's, possible for a designer to say, hey, I know the recommendation is for a transmitter, but in this situation, I really only need a switch. So even though that's the guidance in API that we're moving towards transmitters, and that's the default, it's okay to default to a switch if you want to, if you need to. I'm also looking at the serviceability. As Rich mentioned, on the right there, there's a bunch of features. One of the big features to me is the ability to manipulate, change, and configure the system from the front of the panel and service components without having too much issue. It all slides right on the rack right there. It can be serviced easily. The panel on the left, while completely functional, I'm noticing my process gauge. It does have a block and bleed valve on there, but it's bolted to the back of the panel. Should that fail, it would be awfully challenging for somebody to go out in the field and replace that pressure gauge easily without reworking some of that panel, taking some other components off. So the reliability piece is mixed in with the ease of serviceability as well. We want to make it not just a reliable system, but easy to maintain as well. So when there's an opportunity to use certain things like drop-in gauges with tube stubs, so positioning's easy, removal's easy, use that to your advantage to make this stuff easy to service for your guys. Every little barrier we're going to put in front of somebody to either read the panel, service the panel, should be viewed as a reliability concern. We want to make all this as simple as possible. Okay, so again, designing for reliability. Section in the standard about incorporating vents and drains, and that should be a no-brainer, right? Some of these require vents. What I'm looking at here is a 53B, and what I've highlighted is the connection from the unit to the pump itself. And I want to talk a little bit about the location of vents and drains, because oftentimes what gets very specified if I'm upgrading from a single to a dual seal is I need this type of seal plan. I need a 52 or a 53. It arrives on site, and then we say, okay, guys, hook it up. Well, without an engineer drawing or a kit of parts, we're just leaving a lot up to chance. What are the odds that somebody's going to put in the low point drain and high point vents right where they're supposed to be? So if we forget this opportunity to actually help them install it correctly, we're doing a disservice to the whole system, right? It's only going to work if it's hooked up correctly. And I've been out on sites where I see an inlet and outlet mixed up on a 52. So why not provide the guys with an engineer drawing and a kit of components to show them, hey, here's exactly where we want those high point vents to go. Because if they don't include them, how are you going to bleed air off in the system? If you get a slug of air caught in your seal chamber, you could easily dry run your seal. Maybe the air gets trapped in the chiller and reduces the efficacy of that. So don't just consider that I got the pump and I've got the seal support system. Think about how are they going to get put together and installed. Okay, this is one of my favorite pictures that I saw in the field, designing for safety. There's a focus throughout the standard of having everything visible to operators at eye level. So immediately I'm looking, it looks like a little bit of a disaster, which it is. It's a Plan 32, believe it or not. So down in the lower left here of this slide, I have the ISO diagram that shows you what should be on a Plan 32. And this is the reality on the right, that picture there. That's exactly how it gets built when guys are cobbling stuff together. All right, you've got a hose coming down, right? It's got to do a 90 turn through a headland flow indicator, which, by the way, is at the base plate of the pump. So what do you think the odds are somebody doing their rounds are going to get down on their hands and knees to look at the flow through that? Then it's got to come up through a rusty strainer, a hard 90 through my rusty check valve, and then I have a half-turn ball valve for flow control. So not a very safe installation, and certainly we don't want to use a ball valve for flow control. It's just a pieces cobbled together. There's no indication that it's a system, so lots of room for improvement here. I always think about these systems too as what happens when I have a turnaround or a project and I have people unfamiliar with these systems coming onto my site. And am I leaving it like this drawing here, this picture here, an opportunity for somebody to open or close that ball valve because they don't know that it's being used as flow control? So these are the things we need to think about. And if we don't have good standards and drawings and instructions for people, if you ask them to go look it up in the book and install a 32, this is what happens. This is what I see when I'm out there. So put it on the panel if you can. API wants everything visible to the operators for test adjustments and maintenance right in front of their faces. So we want everything up away from the pump so they're not having to get down on the ground and inspect something. And I just think even though it's not, it doesn't have to be on a panel, plans like 32 or some of the other ones really benefit from being placed on a panel because now it looks like a system. I've got all my key instruments there, flow, pressure, temperature, just right at eye level. So really quickly I can assess what's happening with the system. I can change the regulation with my needle valve, block and bypass the strainer if it needs to be serviced. So really the design on this is intuitive and the functions are apparent by walking up to it. You can see labeling right there telling you what's inlet, what's outlet. Speaking of labeling, I took a picture of this gas panel. It's a 74 to show the power of what labeling can do, and it's something that we forget in the design process, but should be considering. You can see on this 74, which is flowing dry nitrogen into the seal for a dual seal pump. You've got 55 pounds on the gauge, do not adjust, and then next to that top flow meter there, they said at 5 standard cubic feet an hour. Write the maintenance order, then at 10 they will change the seal. So it's just their little indication or their way of reminding them, we know at 5 this is failing, at 10 they're going to have to replace it. So okay, magic marker is one way to do labeling, a little Sharpie pen. But I think, if you look at this example, you can really take this to a whole nother level by using a variety of techniques. You can just, affix labels on there. Here, what you're seeing is a vinyl wrap. So this is the same vinyl wrap that they do to cars. We've done extensive salt spray testing at our factory on this vinyl wrap. It does not fade. It does not, delaminate or anything like that. So it's a good option because you can print whatever you want on there. So this here is a 7276. And just through colors right away, we've denoted that there's a system difference and a material difference. So the 72 is clean dry nitrogen, that's in white, and the 76 is going to take the nitrogen as well as normal process leakage and take it to flare. Well, on an ISO stripper, this could have acid in that line, so they want the 76 portion out of Monel. So immediately walking up to this, I have got my material designator with printed on there as well as a color coding so I don't get stainless and Monel mixed up. What else can we do on the labeling? What else is on here? Instrument set points, right? at the gauge, you have 2 to 3 psi for the nitrogen to the seal. You have that same information on the instrument that controls that, the regulator. So how many places can we put this so it's double checked? Same information. What about other options? You know, bypass valves are labeled, flow control valves are labeled, and you know, the more we work with customers, the more we're learning too that commissioning is a dangerous time for seals and support systems. So even putting commissioning instructions on here can help improve safety and reliability. You can see here they say gas to seal should be first on or last off. So it's just a reminder, make sure this panel is operating and on before we turn our pump on, because typically if they don't have this correct, they're going to damage the seal. Now, maybe that seal is not going to damage to the point of complete failure, but instead of getting 5 or 6 years out of that seal, now you're getting 2 or 3. So consider putting as much information, even commissioning instructions, on or near the panel or pump somewhere, just so that people can reference that during projects and outages. Okay, one of the last examples I'll have there is filling seal pots. You know, in my time traveling around as a market manager for Swagelok in the chemical refining business, I've seen probably thousands of 52s, and they're all filled differently. And the current recommendation from API is to have the fill from ground level. The old way, and the way a lot of places still do this, is to climb up on top of a ladder and take the pipe plug out of the top of the pot, and then fill it from there with a bucket or a little hand pump or something like that. But as you'll see at this refinery, that was an inefficient process. You know, it took them a long time to go down, set up the ladder, climb up and do that. It didn't want people on that ladder. It was a fall hazard. Sometimes they had to shut down the equipment because it was too hot to work on. They had health and safety issues because when you take that pipe plug that I've indicated with that green arrow there, well, now you're exposing yourself to processed vapors. And at 52, the way it works is, you know, the gas is normally a liquid in the pump system. When it gets to the low pressure area, it turns back into a gas, and it bubbles through, you know, your royal purple in the pot. So if you're just taking that plug out, now you've got maybe some processed vapors in there. In real catastrophic situations, you could have that pressure in that pot. So we certainly don't want people just opening those pots to atmosphere and sticking their face nearby. So what can we do? What if you just retrofitted the pot with a fill assembly? So in this particular refinery, over a period of time, they installed what you see here, this valve array and tubing array on the side of every pot. They had pots from Eagle Bergman, John Crane, or Flowserve. So there was no standardization on the pot, but what they did standardize on was the fill assembly on the side of the pot. Now every seal pot is filled exactly the same way. They're able to take a cart, wheel it up, hook it into the bottom of that tubing array, and pump it up into the top of that pot. They don't have to take the system offline, break into it in any way, no exposure to vapors, and everybody's doing the fill from the ground level. So, you know, when we talk about standardization, these are the types of you know, to use a term, low-hanging fruit or easy wins that we try to involve ourselves in, where significant progress is made on reliability and safety over a period of time, without having to shut down massive pieces of equipment. What we did is, you know, over the course of about a year or two, retrofitted every seal pot in this facility with this array. So it wasn't something, it's a journey. Standardization is a journey, and it can start with little things like this. So now we always incorporate that standard design of a fill assembly on the side of all of our seal pots. Okay, I think we're right about half an hour. I'll end here with a you know, example of, you know, looking at these bigger mechanical systems and some of the issues and how to think about maintenance and use tubing appropriately. Here was a maintenance issue on a big pipeline pump where that red arrow indicates behind the pipework there the bearing housing, which was what they had to service very frequently on these pumps. All the pipework in front of it is the bearing lubrication and seal flush system. So every time they had to get into bearings, they had to disassemble that pipework. It took them about 40 man-hours to do. They also had some leakage issues over time. You can see it's an all-threaded system. So, you know, literally guys would have to drive out to, you know, points on, you know, geo-coordinates on a map to go to these pump stations, couple hours to get out there and then fix a leak on one of these systems while they're out in the middle of nowhere standing in a puddle of jet fuel or whatever was being pumped through there. So not safe, not reliable. It was heavy system, so they had to replace it over time. It literally shook itself to pieces over time because it's just vibration in the area. So, they're looking for ways to, how do we improve, not necessarily the seal flush system itself, but how do we improve our maintenance on this bearing system? It's just taking too long to get into it. So this is the exact same pump, but with a tubing system installed on it. So they gained a couple things here. First of all, you can see, super easy to access the bearing housing now. Just swing those two pieces of tubing out of the way, pull the cover off, and I'm into the bearing. So, dramatic reduction in the time to work on these types of systems. Then they went from carbon steel to stainless steel, so they didn't have to have an extra contractor come on and paint it. Their maintenance team thought, well, gosh, it's much easier to get to the filter now. I can actually tell it's a filter, and I can block and bypass it, change it when needed. And then lastly, in terms of the reliability and longevity of the system, they're not sure that they're going to have to replace it anytime soon. Like the other one was 5 or 10 years they would have to replace it. This, we've profiled the tubing around the pump at the places of low vibration, so it hugs the pump and vibrates in tandem with it instead of off to the side like the pipework did and shook itself to pieces. So this is just one way you could implement tubing or use tubing on these systems to replace pipework to address a maintenance challenge, which was really not even related to the flush system. It was more related to the bearings. So I thought I'd just give you that case study as an example. Okay, so just to wrap up, thanks everybody for your time. There are advantages to tubing, and certainly reach out to your local sales and service center and Richard here if you have questions on how to implement tubing in these systems. But really, the big concerns are designing for reliability and safety. Let's just take a time when we look at these systems and not think of them as something that arrives from our seal vendor and is going to work perfectly. It's got to be connected, it's got to be maintained, and it's got to last for a long time. So how do we simplify operation maintenance through better design? Okay, I'll take any questions now if anybody has any questions.
Let's see here, Sean. Let me have a look here. And there's one new question here. So the question here from Anonymous is, how will a mechanical seal support system perform on a pump and seal that appears on the edge of its design limits?
Oh, that's a tricky question. So without getting into any kind of specifics, right? I often think of a seal support system, and really the seal itself, as the initial warning sign that something's not correct. So if something's operating at the edge of its design limits, and you're seeing seal failures, the first thing we'll do is root cause analysis. Why am I getting failures in this system? And then if it's traced back to something such as the seal or the support system, questions are, do I have the right seal? And then in the support system, am I getting the appropriate flow, temperature control? Really, when we look at support systems, all they're doing is delivering a gas or a fluid into that seal and maintaining the proper temperature, pressure, and flow in that system. So, in some senses, the seal system won't care that it's operating at the design limits, as long as it is designed appropriate to handle those conditions. And you're not just grabbing something off the shelf and then pushing both the pump, the seal, and the support system to the design limits. Try to make sure that the seal support system is designed appropriately to handle anything that would be outside the normal.
Thanks, Sean. There was another question here. Will Swagedock evaluate existing systems? And yes, of course, we can come in and evaluate your existing seal support systems. That evaluation is limited to the seal support system. So we, as Sean introduced earlier, we are not pump experts. We're not seal experts, but we are fluid system experts. So if there are issues with the pump or the seal itself, those are not things that we could evaluate. Certainly, making sure that you have a good supply to the seal is something that we can help with, and we do that on a regular basis.
Yeah, Rich, and a lot of times our work on that is going out, looking at the system, comparing it to best practices in API, making recommendations on ways to improve the system for those key points of reliability and safety. And then we would like to rank those on concern with a potential payback or return on investment for doing each of those upgrades. Because certainly there are going to be some things that, although it's a best practice, it's too expensive or not necessary to fix. So we always try to focus on which one are you guys going to get your highest return on investment.
Yeah. Okay. There were some other questions that I responded to in the chat stream. There are no new questions that have come through.
Okay.
The one question that came early on, Sean, and I did answer this with a one line, but the question is, are these systems dependent on the type of seal used, or do they need to be modified based on the seal type? And my initial response was that our systems are compliant with API 682 seal layouts, and they can be customized for the particular application or the site requirements. You want to expand on that a little bit?
Sure. So the seal support system is always defined by the type of seal. Okay. So whenever there's going to be a seal data sheet that's going to tell you right on there exactly what is the recommended seal type, seal support system. So it'll just say it needs a plan 72. Okay. Then we would go into API and use our standard design for a plan 72, but then also work with you to make sure there aren't any other considerations that, because of methods of failure in the past, process upset conditions, etc., that there aren't any other considerations we have to worry about that would modify that design. But it's always, the pump and the seal are dependent upon the duty and the service of what your process conditions are, and the seal will always, the seal manufacturer will always say, here's the plan I need. There are instances where you would go completely outside of anything API related, and they call that a Plan 99, which is a custom engineered design. And that can really run the variety of its, aspects of some other design that incorporates maybe extra filtration or something like that. So that's really all it denotes, and there is latitude within that to add or subtract components as needed. And there's just going to be pluses and minuses to doing that in each individual case, and that's why we're on site trying to work with you or discuss the whole conditions, the process conditions, and the maintenance conditions with you.
Yeah, exactly. So, and that's key. We're more than happy to come on site and have a look at your specific applications.
I mean, one of the simple things, like sometimes that we see is, they'll have something where somebody turned off the flush flow to a seal accidentally. And it's as simple as putting, locking handles on valves or orienting the valve in an area with a sign on it says, do not actuate. And these are just the simple things that can really pay off if you have those types of failures where, people are just doing the things that people do. So how do we engineer and design a system that I don't want to say idiot proof, but, addresses those common human and personnel issues that we have with these systems.
We have one more question here. And I'll read it out here. Are there mechanical seal support systems for sealing equipment with high thermal expansion? I think this is probably more of a seal design question than a support system question.
Yeah, again, I mean, just generally speaking, the design of API pumps, which is governed by 610, are designed to handle thermal expansion. If you're having seal issues due to thermal expansion, I mean, that is something between the seal vendor and the pump manufacturer that you really want to discuss with them. If the thermal issues are related to the chambers getting too hot, or you're not getting flow because things are, getting cooked within the seal chamber, you're getting coking on the backside of a seal. Those are all things that support systems address, right? However, the actual, thermal expansion within the pump or the seal itself would be handled by the guys with those expertise.
Okay. Thanks, Sean. I don't see any new questions. I will say that early on in the Q&A, I did share links to our application guide and our configure and quote tool. So if folks have additional questions, they could refer to those links. I believe Katie will be sending out a follow-up email with links in it as well. And if you have any applications that you'd like us to look at, or you can contact your local salesman, and we'll get in touch with you and have a look at that application for you.
Also, Richard, when I send out the thank yous for attendees, I will also include a link to the recording for anyone within your company that may not have been able to attend, or if you'd like to share it out through amongst your company, just so you're aware it will be available to listen to afterwards.
Perfect. All right.
All right, Richard. Well, if you guys ever let Americans back up into Canada, let me know. Maybe I'll get to see you again in the future.
Absolutely. We're looking forward to that day for sure.
Yeah.
All right, everyone, have a great day. Thanks for joining us, and we will see you again soon.
And
Thank
thank you, Sean, for presenting out with us as well.
Yes.
Thank you. Thank you, everyone.
Yeah.
Thank you. Have a great day, everyone.